Okay, so I think this is the majority of all the people I think were going to come. So we might as well just get started. Today I'm just going to walk you through some of the basic stuff. And most of the information is already in like the user manual and different tutorials and stuff like that that are available. But I think sometimes it helps just to walk through it with someone, just in case you have any questions. Cool. So first off, I'd like to just, remind you of that user manual. So if you just go onto like the Moodle page, which is under like the interest groups tab, and you can self-enroll yourself, you'll then, see this page, and it has all useful information, like our Trello page, the Discord channel, like obviously you know about that, and mainly the manual as well as some resources that you can download. So if you haven't ever done this, please, have a look at it, and you can just open it. I'll just open a new tab, and then here's the actual link to it, and it opens this. I think it's a markdown book basically, and it has a ton of information like I've spoken about. But the key thing for today is we're going to go through like installation just briefly and some getting started type stuff. Where is that? Over here, getting started coding. So can I ask firstly, has everyone managed to actually go through the installation process, and has that been smooth? Or have there been hiccups other than the one that we solved already?
Yeah, no, it's okay.
Okay. Can I say that's true for everyone? Or at least the majority? Cool. So if you've managed to install, then I hope you also managed to try, run each of the three components. So let me do that now quickly. So how it works is that we've basically compiled everything into like a singularity instance, except for the agents, I guess. But you can run that by either running this RoboCup NVIDIA or RoboCup Mesa or Mesa, depending on if you have a graphics card, like it says here. And that'll open up an additional terminal, and this is basically where you run all three of the components. So the first one being is the server. So RCC RCSS over 3D, and you can auto finish that if you need to. And this is basically indicating that the server is running and it has all these errors, but don't worry about that. That's not a big deal. And then I like to just open multiple tabs by right-clicking anywhere in the window and then new tab, and just having each of my different components on different terminals. The other one that you need to run is the visualizer, so you can actually see what's happening. And that's done as so. And that'll pop up another window. So it is kind of annoying that there's all these different windows, but what can you do? And now this will also look a little weird because the fields aren't marked correctly, and sometimes the goals don't load properly, but here you can see that they are. And if you're a little bit confused about like camera controls and stuff like that, like zooming in, I'm using my mouse wheel. There is a video tutorial specifically on that. Once again, in the book, you can go to it just to move around and have a bit of, understanding how things work. So that's the second component. And then the third component would be the actual, well, the third and fourth, if you're running two teams at the same time, would be the actual agents. So I have uploaded, once again on the Moodle page, our like most recent, up-to-date, current best version of the code base. So we started with this UT Austin Villa code base, and that had a lot of the stuff already done. Then we developed this like not so clever bot. I think that was like a year back now. And now we're up to this team called Public School Heroes. And this is like a collection of what we've learned over the years. So what I recommend you do is download that one rather than starting from the very base, because we don't want to start from scratch. So you can click that, download it, and it will obviously be in your downloads folder. And I actually have downloads folder open already. No, I do not. So it would be in a zip file in your downloads folder. I've currently got it here twice. And all you would need to do is unzip this. You can put it wherever you want, but I'm just going to copy it to my home folder, which I have it here already, but I'll delete that one. And then you would just extract it here. And this one would be basically good to go. You can see inside that folder, there's another folder. Inside that's the actual team. And this is the same structure you would see from the UT Austin Villa code base, which is what it tells you to do in the instructions, right? This one here. Now, and that's fine, because it's the same structure. It just has more things in it, more things you can use. Cool. So there is a few things that you might not have, or that aren't in the instructions with running a new team that you've downloaded. So I'm going to walk you through those now quickly. Where am I? So now if we come back to our like Singularity terminal tab for the agent, if I go ls, obviously it's just your desktop or your home directory, and you can see this folder there now. And we'll cd into that. Oh, what was it called again? Ah, there we go. Dev grim, the backup one, ls, and you can see that was that other like subfolder. And we ls again, and you can actually see the project itself. Now, in order to run a project, just like it says in the tutorial guides and all that, you just use the start.sh file. And we run that, and you can now see it's loading the agents. You can see it's running agent number 1, number 2, and it's just 2 agents. And that's because inside that start.sh, we specified the number of players to be 2. Okay, so that's why it's only 2. And another interesting thing is the code that you like compile and run, that code is run each time for each agent that you specify. So it's like a duplicate of the code running for each agent. It's not a singular like file that then controls every agent. It's the same file running for each agent, if that makes sense. So that means inside your code, you have to, you know, do clever things to specify different behaviors for different agents. Otherwise, they'll just do the same thing. And that's not good if you want the one player to kick the ball into the goal and the other player to defend. You have to do clever things to get around that. Well, so now you can see that the player is actually loaded in. Their team name's been added to the top. The agents have been placed where you specify. And the field lines are actually fixed. I don't know why that's happened, or why the server doesn't have them fixed originally, or the visualizer doesn't know. But yeah. And if you wanted to run another team, well, you just open another tab, and you can run another team like that. So you could do start.sh again, but because the teams are the same name, it won't work. So how I get around that is I have another start.sh file that's just exactly the same, just copy paste and rename to start.sh2 or start2.sh. And I can run that. And if I open that file up, this has a different team name. So it will be fine. So you can see now I've run the same code or the same team twice, but with different team names, so it works perfectly fine. So that's just something to look out for. And then now if I go like kick off left, the game will start, and you know the actual AI or behaviors behind the things will take over, and they'll play from there. So let's do that just briefly. And you can see all these numbers all of a sudden display. And that's just because I like to keep track of like some information, like the quadrants of the field, and I draw that to the screen. And the drawing is a future thing that you can look into. Again, there's a tutorial that explains it. I'll actually show you now. Once again, inside the user manual, if you go to long form tutorials, there is, I think it's tutorial 1. And there, demonstrate the use of RoboViz drawing feature. Now this will take you through exactly the process of like what code you need to put where in order to draw things to the screen. If I also go down to, I'll go up to the field page under class breakdown. I also show exactly what code you need to draw like these lines in order to like mark out sections of the field. And while I'm on the field, it's good to have a read through this to understand, okay, where are my X and Y coordinates? So 0, 0 isn't like top left corner as you might think. It's actually center of the field. And then left of that would obviously be decreasing in the X, and right to that would be increasing in the X. And you can see that here where we have -5 and 10 and 5 and 10. And then up would be positive on the Y and down would be negative on the Y. So interesting how we determine like the center of the goal is basically we just look for half the length of the field in the Y coordinate. So that's why you can see here -half the field Y and half the field Y would be on this side. Cool. So have a look at just understanding the fields a little bit. But again, that's a little bit in the future as well. Are there any questions about like running the agents and stuff like that? I think we still have our agents running, right? Yeah. So also you can just toggle the drawings on and off, just as if it's too confusing. Just like by going to view and then, you know, playing around with some of the settings. Cool. So everyone happy with like running each of the 3 components, you know, with the different terminals and tabs and stuff like that? Awesome.
Yeah.
Now there are 2 ways to stop the actual server. You can either go to the server tab and then like Control-C, or you can do it within, and I find this a lot nicer, to go within the actual visualizer and then say kill server. And if you press that, you can see it now says trying to connect, because it can't actually find the server anymore. So that's why it's like this grayed screen. And if we go to the server tab, you can see it's no longer running, right? So I've got like control back in the terminal tab. And then I can just rerun the server by just, you know, pressing up and running the old command. And now you can see it's no longer looking for the server, it's found it, and now you know it's connected as well. Cool. Okay, so that's the first part, running, installing, running. And now let's have a look at like editing some actual code. So I like to run things in Visual Studio Code, but it's not necessary which specific IDE you use. You could even just use, you know, like the text, like a text editor. I don't recommend it, but you could. And in order to install like Visual Studio Code, if you haven't already, you can just Google how to install it. Pretty easy instructions here to just, copy paste into like a terminal, follow them. Pretty straightforward. Or I found you can also go to like Ubuntu software in your search, and you can look for it in here. Oh, it's right there anyway. And then you can click on that and you could say install. And I think that will work as well. So again, that's just something you can like have a look at doing. That's if you want to use Visual Studio Code. If you want to use something else, go right ahead. Cool. So editing an actual project. So I will go into Visual Studio Code and I just want to open the folder in which my code is. So if you remember correctly, I went into home, I then extracted it, and you can see here's like the UT Austin Villa master one, so I could actually open this one if I wanted to. And then I go inside it and I open it to a point where I can see like scripts, behaviors, all the actual files. And then I open and I press OK. And now it will show everything in like this Explorer over here, which is very handy. Now I'm going to just run through a like the processing cycle of how the server and the agents actually interact. And just like any code that you've ever written, you always start at like a main file. So we have a, just in the like the root of this project, you have a main.cc, and this is obviously the, you know, the file that gets, you know, called first or gets put onto that processing stack first. And there's a lot of stuff here that I don't even know what it does, and it's not super necessary to know just yet. But when we figure it out, then we'll add it to any sort of repository or anything we need. The key aspects to know here is within the main CC file, there must be a main method, of course. So I'm just scrolling down. Again, all these other functions that you don't really have to worry about too much. I know it looks daunting, but you don't have to think about it at all. Cool. So there's a main method, just like you would have seen in any, you know, C++ file. And inside here, there's a couple things that I just want to touch on. Firstly, this read options function. You'll never have to know how it works, but all this does is like it reads in some configuration type stuff. And some of that's from the start.sh file that we've touched on briefly, and some of it's from other like metadata files. And that's just to, you know, understand what's, you know, some of the characteristics of your project. And then inside this try catch loop, there's a run function. And inside the run function, yeah, I think that was the one just above here. What it does is it creates a new instance of like a particular type of agent. So what I mean by this is, you remember I told you that each agent is basically runs its own set of the same code, right? So here we're actually defining that agent as like an object, because our little guy that you would see on the screen here is basically just an object. It has some like methods attached to it, some parameters, stuff like that. And we are simulating the now agent, so that's why it's this one specific. But there are other types, but again, you don't have to worry about that. And here you can see it's loading the team name, the unit number, which is the actual like player number, and this will become important later on, and then some other parameters that not really necessary. So it creates an agent basically here, and information not necessary. It gets to a while loop, and this is basically like while not finished type of game loop type thing. So while the game is still running, do all this stuff. So this is the loop that it sits in for the entire duration of the game. And how this works is it receives a message from the server. It then thinks about this message, and then, you know, sends a message back to the server explaining what it wants the agents to do. And that's the basic, the cycle. So again, from this main method, we want to travel into this think method, because that's where the actual thinking happens. And this is inside the behavior class. So there's a folder here called behaviors. And we need to go to behavior CC, now behavior CC, sorry, because it's a now agent. And again, this is just another file filled with code that you don't really have to worry about too much, so don't be scared. And it has a think method. And inside here, it basically converts that message from the server into useful information that we actually can use. So it determines like states of the match, like what is the different, what play mode are we currently in, the status of the different agents, like have they fallen down, stuff like that. It also calculates the different positions for all the agents. But again, just like configuring some statistics as well as like metadata, you don't have to worry about it too much. The important part is that it has an act function that it's calling. Where is that though? Here. So this act function is important to us because it's like one step away from where we can actually get hands-on with the code. And this is what I was referring to. Like checks if your current agent is falling down, like if it's moving and stuff like that, how far things are away from the ball, what type of walking model I should be using. Again, not super important to know. The thing that is important to know, and I think I've missed it, but it's, here it is, the select skill. So this is the actual function where we want you guys to actually put some code in that determines what our agents do. And the select skill function can be found in behaviors strategy CC. So this is the actual file that you're going to be working with, strategy.cc. You very rarely, if at all, will ever touch any other file. So yeah, this is the one that you should be familiar with. Now, inside strategy CC, I'm scrolling up, and this is all code that we've written, by the way. So there's a select skill function. Okay, and that's that same select skill function that we were talking about a few seconds ago. Now, this is where we're going to return something for our agents to do. Now, our, what was this one called? Public School Heroes team. This is the code that basically runs that. Now, it's a lot of code and maybe it looks confusing and stuff like that. There's a lot of commented code as well. But in essence, all it is doing is telling our little agents to do one of three things. Okay, those are to kick the ball, all right, to go to some location, or to stand. So if you think of it in terms of like, what are the actions my player can do? It's just those three: kick, go to, and stand. And you don't even have to program the kick function or the go to function or the stand function, because we like those are already done. So he has the kick function, kick ball, a kick type, and then a destination or a target that you want to kick it to. Now these are all being done for you. The thing that we have to come up with is some sort of complex or clever behavior that determines when we do these things and in what situations. And that's all this code is doing. So you can see there's a lot of like what you would expect to see in like first year or whatever, like just if statements, because that's all you really need in this case to come up with something pretty cool. It's like, if in this situation, well then do this, or don't do this. And obviously there's, I'm summarizing or playing it down a bit. There's some like clever functions like is an offensive strategy or is closest teammate. But again, those things that you'll get into. Cool. So are there any questions so far in terms of like the code base, how to find things, stuff like that? Okay. So again, just to summarize, select skill, this is the function where you want to be playing around in. Obviously you can make your own little functions and then return something here, but this is the main function. So what I'm going to do is just comment all of this out because it's not super necessary. Yeah, up until that. And how do I do that? Should be a comment out. Where is it? Edit? Yeah. Line comment. Okay. So everything inside my select skill function is commented out. So there's nothing there basically, except skill stand. Okay. And remember when I said those three actions we have are kick, go to, and stand? Well, if you just want your agent to stand still, this is all you do. You just return skill stand. And if you wanted to kick, well then you kick here. If you wanted to go to someplace, then this is the one you can use. So there's a lot of like useful commented out code in here as well to look into. Cool. So now how you would get our agents to actually do this is you would need to, save it. So save all. I used Control Shift a few seconds ago, so that's why it's saved. And it would also tell you nicely that some things weren't saved. And it's important to know that you have to save everything. Otherwise, when you compile it, it won't carry those changes over. Yeah. Cool. So now in one of our little agents tabs, and you can see when I close the server, this, it told me here as well. I just press enter once, and now I'm back in control. We can actually, compile our agent. So what I'm going to do is type make, okay, and it's going to go through our project, looking for any changes, and then compile those. So we just got to wait a few seconds, and there it's done. And you might be thinking, okay, well, this is all great. But what I'm going to do now is do something like this. Take away the semicolon. So we all know there's a problem here now, right? Biggest commonality or common error ever found is leaving semicolons off. And it's also telling me, look, there's like a little red line here. I can see there's an error. There's a little squiggly line here saying I'm missing the semicolon. So we know there's a semicolon missing. We know there's an issue. I'm going to type make again. Okay. And it's going to go through the same process. Now you would expect it to pick up on the error. Now the issue here is, since we've copied a project for the first time that's been compiled somewhere else, or hasn't been compiled, but it's just for the first time, you need to do the cmake space dot. Okay, so you must remember to do that for the first time only. And if I do that, an error pops up, and this is good news, okay, because this is what I expected to see. So because I've compiled this prior in like a different folder, our cmake cache file is actually incorrect. Okay. And if you read this carefully, it tells you why. Now, what I need to do is just quickly delete that file. So inside our file explorer, we can go to the cmake cache.txt, and you can simply delete it. You don't have to be afraid of breaking something. Just delete it. And then I can go cmake dot, and boom, we're working now. And that's simply because the directories in which this file was originally compiled, this project is different to what the cmake cache.txt file said. So you might be able to actually just go in here and fix the directories, but I'm too lazy and not that smart. So I'll just delete it and redo that. So now we can type make. And this time it will take a little bit longer because this is the first time we're making it now. It's like we've cleaned it and now we're building it for the first time. So it's going through each of the files and making them, in the correct order one at a time. So I'm just going to have to wait a little bit for that. And while that's happening, if you do have any questions, please let me know.
Yeah, Brandon.
Yes.
Is there a way to kind of run the games without the visualizers? Just get the results and some log data?
Yeah, so you don't have to run RoboViz.
So yeah, and also...
So in the server then, you have to run the start command. And I'm not 100% sure off by heart what that specific command is though. But you would go to the server here, and then you can say kickoff left. I'll just have to look that up for you.
Okay, cool.
Yeah. And then yes, you can log everything to some output file.
Okay, neat. Thanks.
Cool. So now we made it, and look, that error actually appeared. So you can see it's working with the correct project and it's doing things correctly. So if I just go semicolon now, and then save it, you can see it says one unsaved. So I'm going to save it. And which terminal we are. And now make. And it won't take as long as it did before. Well, actually it will, because it didn't finish compiling. You see it only got to 12% there. So it will take a little while. And while it's doing that, I'll actually explain the benefit of using an IDE. The reason why I really like to use this is because you can search for where things are implemented. So I've briefly alluded to that this gets unum will return like the individual agent's number, which is unique to it. So if you have 2 agents on the field, one will be player 1 and one would be player 2. So what you can do is you can see, oh, okay, this is within the world model. And if I want to see what the world model is all about, I can go to like a definition, see where it was initially declared. I can see that's in this like now behavior file. And maybe I get some useful information from there, or I don't. Or I can go specifically to see where get unum is declared. And you can see here in the world model H, it's declared. And then what does it return? Unit number. And then, okay, well, what is unit number? And you can go to the definition of that, and that's, okay, that's declared here. And you can see how you can move around the code base a lot more efficiently than if you were just in like text files, or not using an IDE. So that's super useful. I like using it for that. And that's a lot of the reason why we've discovered how things actually work. So like this half field X was one, like if you go to declaration, we can see, oh, okay, it pulls me into the field file, which is under headers here. And it says half field X is equal to field X divided by 2. Okay, that makes sense. Well, what is field X? And you can see here it's equal to 30. So that's how we knew the size of the field and, you know, the sensors of the field and the goal positions and heights, etc. Was through searching, basically. Cool. So we're at 60%, so we're still busy with that. Is there anything I can tell you about beforehand? Not really. Again, a lot of this information is in our, guides. Specifically like our class breakdown stuff. I talk a little bit about, it's not super in depth, but it has just what you need. Like skill types. If you noticed sorry to jump around all the time. Our select skill function returns a skill type. So this is ultimately what you need to return, something that is of type skill type. So in our book, these are the different skill types that you can return. Now, I specifically said it's basically stand, kick, and go to. Go to is actually not here. But they are like kick left leg, kick right leg. But I mean, again, those aren't super necessary. They kind of like summarize into just kick and go to. Again, like body model. Okay, the body model doesn't really have much. Another useful one is vector position. And this is what you'll use to give like positions to go to. Now it isn't 3D, even though, it's basically a 2D world that you need to move to. So the Z component very rarely changes. But there's a lot of useful stuff here to do with how to handle targets. Cool, so it's done. So now that it's built, let's just double check our server is running and our visualizer has connected to it. And our agent's compiled, so now we can actually run the agent. And that's again just by, start.sh. And now our one agent is in there, or our one team rather, with 2 agents is in there. And what I'm going to do now is just show you something useful. So you remember the start2.sh is just a duplicate of that one. So I'm just going to open this with a text editor. So what's useful to know is this file can be changed without recompiling. So if I just change this quick to like test, spelled with too many capitals, and then in our second tab, run that, you see it still works perfectly fine. I could even change the number of players and it'll still work fine. And now I go to my visualizer and you can see it's team test and public school heroes. So yeah, that's just something to note. And now if I go kick off left, all of them are just standing still, right? Because that's what we told them to do in the select skill function, right? As soon as it comes into here, which is where like when the game loop stops after getting all the metadata and configuration stuff set up, it does whatever is in this function, which was just skill stand. And that's what they're doing. So that's good news. Now, the important thing to note is whenever you make a change and you want to like re-visualize and see that change, you have to kill the server, you know, compile the code, rerun the server like so, and then add the agents in. It's a bit of a laborious process, I know. The only thing you don't have to rerun is the visualizer. Sometimes the visualizer does like mess up though, and if you've seen some of our videos of like the tournaments, all you need to do is close the visualizer and then rerun the visualizer, because the server's still running in the background. Obviously everything's still happening, you just can't see it. So yeah, that's one case where you need to run the visualizer again. Cool. So any questions in terms of like manipulating the code, running it, the process to edit stuff like that?
Sorry, I have a question.
Yes.
So you were saying that the only thing that we need to worry about is the select skill function, right?
Yeah, yeah.
Okay, cool. And then another thing, we'll be getting like a template, so like with all the files and then with just that function cleared out, or
so yes, if you go to Moodle, you can. What I'm working with right now is this project here. Okay, it doesn't have it commented out or blank at the moment, but what I can do is upload a version where it is blank but have all the code like in a separate function that's called, just so it's cleaner for you. But what you can do is just delete all of this if you want. But I would have a look at it first just to see how things like operate, because there's a lot of cool things like doing different things when it's a different game mode, like if there's a penalty, or you know, if it's the opponent's kickoff, maybe I should move to a specific location rather than, you know, doing the same thing. So yeah, I will clean it up a little bit. But yes.
Sorry.
No, go ahead.
Okay. I was asking if because I saw there's different player types. So I saw like PK, goalkeeper, something like that. So do you also have to take that into account when we what's it again? Coding select skill.
So not at the moment, no. The specific one that you saw, I think, was in like the main method, and that's you see this code base has capability of running other games in essence, where it's like a kickoff game or like a passing game, not like soccer specifically. And that's where those guys come into play. So like I said, you don't have to worry about that.
Okay. Yeah, I think that's it. Thank you.
Cool. Okay, so one thing I'm going to do now is the last thing, I guess, is, well, two components. Firstly, making our own little function. And then the second one is telling different agents to do different things. So again, this is in the book. Under getting started coding, assigning different tasks. So this is what I'm going to be like referencing now. And there is another video of me doing this as well, when you can see the side-by-side code and what they do. But yeah, that's what we're going to do now quickly. Because there is a slight trick in terms of making your own function. So you can see, if I scroll way down, like demo kicking circle is another function that returns a skill type. And we could just return this here. And it would do like a cool behavior. Actually, let me just do that so you can see. So we need to compile, but I need to change my start.sh file quick. This is start to, I'm going to put 11, not 211, 11 players. And now what this is going to do is inside skill, select skill, it's going to come into demo circle and then return whatever demo circle returns. And because demo circle returns an object of type skill type, well then we're happy. So I'm going to come to terminal, the other one. I'm going to type make, everything's saved, yes. So now when I make it, you'll see it'll be a lot quicker because it's not making every single thing. It's just going to make stuff within the strategy CC because that's where I changed stuff. Cool. Server running, visualizer running, that's running. So I go start.sh. I need to do start2.sh. So again, you could just have both agents running in the same terminal, but I like to have them separate just so I can see if I print things to screen from different agents that, displays on the separate ones. Okay, so you can see here running agent number 11, so it loaded all of them, which is what we wanted to see. And now you can see they're all kind of like messed up here. And that's because I think this code actually just drops them in the middle, which is not ideal. Unless okay, this is a good example of my visualizer breaking. So I'll close the visualizer and wait for my computer to stop freaking out. I said I'll wait. There we go. Okay. And then I'll rerun the visualizer, and hopefully things aren't completely broken. But they might be because... the server crashed. Okay. So just close the server terminal and then open a new one. So I think with that specific code, I think they have to be loaded in on the left-hand side because it's more of a demonstration thing. Yes. So let's go back and open server and new tab. Open RoboViz. It's concerning why it's black. I'm gonna be honest with you guys. This is very concerning. Unless I think I still have an old server instance running that I might have to like p-stop or something. Okay, that agent's not running. That agent's not running. Let's just see what happens. I think I have to kill the server in, what's it, PS top, if I'm not mistaken. What is it? To see all functions, PS?
htop.
htop. What? Is one server still running? I don't think so. Very strange. We come back here. The visualizer closed. I'm just gonna assume it's gonna work fine now. No, oh damn. I honestly don't know why it's not working. Maybe don't run that code. Okay, I'll have to fix that a little bit later. Or we could just close everything actually. That sounds like the way to go. When in doubt.
Just restart the computer.
What's it? Rubicup and video. That is my solution to most things.
Yeah.
It doesn't say that it's complained. Okay, it seems like the server is fine, but I could maybe run the server on a separate IP address and see if that joins better. Okay, I'll have to fix that later. I don't know. Anyway, what I wanted to show you was, and I'll show you on the book video to be honest, is what you can use to determine different behaviors for different players is that U number. So it's a simple bit of code to basically just return that from the world model, and our world model stores like those functions which you can use to access things revolving around the world or the game itself. So world model should be here. So body model is for like the specific agents, like joint positions, and I can show you like the different angle, min-max angles that they can be in, like the gyroscopic like rates and centers and stuff like that. And again, this is not what you need to worry about. The world model is with the information that you need to look at. And it has stuff like what's the current play mode, the score for the left and right hand side teams, U numbers, like the side you're on, if you're on the left hand side. Well, if your team is like said to be on the left hand side, not necessarily if the player is on the left hand side. So if you like kick off from the left, that was your team, then that side maybe will tell you that. A list, very useful list. You'll be referencing this a lot. A list of world objects. So basically each agent has a copy or their own version of this list, which stores the different objects in the game. So this includes players, like your own teammates' agents, the opponent's agents, the goal, like the 3D object of the goal, as well as the ball. And this list is obviously bigger and smaller depending on how many players on both teams there are. So again, the thing with this though is it's not a ground truth. So when I use this list to get like an opponent's position, right? Because I can use this to reference this object's position. It is the position that I perceive that object to be in. So agents have a camera, right? The actual robots have a camera, so the simulated robots need a camera, and they look out with their vision, and they determine, like, based on this vision, the position of the opponents. So it's an estimate, and everyone's positions will look different. That's why I know it's hard to remember back, but when I was running the agents initially, it had all those numbers. And those numbers were close, but they weren't exactly the same. And those numbers were actually like the position of the different players to the ball. And that's why there's like this confidence thing here. It's like, how confident are you in your understanding of the world? So that's something to understand. But what's really cool is that you guys don't have to program like the computer vision that takes the camera input, converts it into like a mathematical thing so you can determine the distance from things to things. You just can reference this one array, which is super useful. And it's of type world object. And if I go to world object here, you can see it tells you all the different things. This is the potential different things that can be, and these are like little enums. So these are just like integer values, which you can use to reference as indexes the specific agent you want. You can even get like the head positions and arm positions and stuff like that, but you don't need to know that. You just use these ones. As well as the ball. That's another world object that you'll be looking at. And then the goalposts if you really want. Like the left goalpost on the left hand side, the right goalpost on the left hand side, and then vice versa the other ones. And then the corners if you need those. So those are there as well. So yeah. So unums is what I wanted to show you. And unums basically return like these things here. Like the index of the player, the current player. If I go back to the book now. So that's why you use this world model is equal to get unum function, because that's what you want to get, right? That returns this agent's player number, a unique number that you can say now, well, if I'm player 1, then I want to do this. if I'm player 2 or another player, then I do something else. So the code example here is what you can see there. So if I'm player 1, I want to actually kick the ball to the goal. Okay, so I return the kick ball function, and I give it a type of kick called kick forward. If you come in here, there should be a page that talks about different kick types. And in the code, there's a lot of different kick types commented out, but it's kick forward, just plain kick, and then kick underscore IK, which is inverse kinematics K. So that's another one. And then a destination. And once again, that falls into that vec position. So it's just basically an object that has an XYZ component, and that's where you want to kick to. And if you're not player 1, well, then you just return stand, and you just stand still like we saw already. So I'm just going to play this rather than code it because the visualizer is broken. So hope you can see this video, right? Yeah, you can see it. Okay, so you can see me just coding it here. And you can see, look, I'm in the select skill function, right? And all the other code just hidden under here, commented away. You can see it on the green over here. And this is the exact code that you would need to run for the behavior that we're going to get. And I don't even know if I don't even display the behavior. What is wrong with me? Ah, here it is. Sorry, wrong video. So after you would type this in, you need to obviously compile it, save it, and then run the agents. And I'll just skip ahead a bit. Cool, you can see it's compiled in there, and now we go here. So again, this is the entire code that I've added, and then this is the behavior that you see. You can see the one agent, as my black mouse friend there is showing, and over here is player 1 that's kicking the ball. Not the best kick, I must admit, but he's going to be kicking the ball all the way towards the goal. So this is how you basically assign different orders to different agents, even though they're going to get the same copy of the code. Even though they're getting the same copy of the code, obviously they're going to be doing different things. So that's why if I come down into tutorial 2 here we've actually made a tutorial where we implement what we call a decision tree. And this is along the lines of what you guys need to be thinking of in the future couple of weeks. Designing some sort of tree that says, okay, in these situations I want to do this, and okay, if that's the case, then okay, maybe I need to consider this thing, and so on and so forth, in like a tree-like structure. And you can follow this tutorial to see exactly what I mean. So again, there's a lot of tutorials that I have already made that you guys can work through. Okay, so the last thing I'm going to be speaking about, unless there are any questions, is what functions we have made. So what I would like you guys to do after you've become a little bit familiarized with the code base is come up with an idea, like a strategy or some behavior that you want to implement or you think might be quite effective. And then start thinking about, okay, if this is what I want to do, what problems do I have to solve? Okay, so if I want to go to the ball, if I'm the closest, well, then I have to figure out how to code, like, am I the closest to the ball? So start thinking about it in those terms, and then come here, as well as look at the code itself, and have a look at these functions that we've implemented in this, like chapter 12. This is a breakdown of like the really cool functions that we have added to the code base ourselves. So there's stuff like go to field position, there, kickoff. So maybe when you're defending a kickoff, you want to do something different to when you are kicking off, which makes sense. So here's an example of in a 2-player game, you can set different kickoff positions based on, you know, a condition. But the really important ones are this distance to ball array teammates and distance to ball array opponents. So what this does is it creates an array that keeps track of the distance all the distances between the opponents and the ball. So obviously if there's two opponents, then this array will have two values in it. And it does the same for your teammates. So what you can do with these arrays now is then do some decision making, like to determine if I'm the closest player, is the teammate closer, is the opponent closer than I am, maybe then I should go defensive, or maybe I should go offensive if I'm closest. So these two functions are really important. And then with having that strategy idea in the back of your mind, look through all the other functions here to see if they help solve your problem. Like we have a function that tells the agent to face the ball. So maybe you just want the agent to stand still but face the ball as it moves around. Or then we have a face ball function. So yeah, think about a strategy, then look through here to see if we've actually implemented a lot of the core concepts for that already. And if we haven't, and you're struggling a little bit to figure out, well, okay, I'm new to the code base, I don't really understand too much how to implement it, then put the question up in like the middle on Discord, and I'll definitely have a look and see how we could implement it, and I'm sure other people who know might also help as well. So yeah, feel free to ask anyone. Cool. I think that's all I really wanted to go through. If there aren't any questions specifically, if you're brand new, have a start with this getting started coding. It does these super simple, like just one line behaviors that demonstrate these functions, like go to target, which was that other action I was talking to you about. And then you can build up into like the more complex stuff and like start implementing your own thing. Cool. So are there any questions? And I'll pop back onto Discord here to see. Awesome. Okay, so no questions means I either bored you to death, or I did an okay job, or you're just not interested. And I'm happy with a 33% chance that I got the one I want.
No, that's really useful. Thanks, Ben.
Okay, perfect. So as you go along, ask me any questions you want. Some things I might not know, but that's good, because then we have to figure it out. Awesome. So a little goal for this week would just be get familiarized, maybe do a couple of the basic tutorials, maybe do one of the longer ones. And then next week you can start thinking about a strategy. And then in the weeks after that, we can implement it in like a team type structure. Cool. Thank you guys. I hope I didn't take up too much of your weekend, and I hope the rest of it is pretty chilled.
Yeah.
Cool. Thanks.
Yeah, thanks, Brendan.
Awesome. Cheers, everyone.
Cheers.